Ranger 2, prepare to detach.
What? No! No! Cooper!
3.
Cooper, what are you doing?
Newton's third law. You gotta leave something behind.
Hello Ziad. So this question 2020 paper 2, student uses different methods to determine the refractive index of the block. Okay, so lots of info. Right, so table 1 shows the readings made by the students. So refractive index n of the block is given by this formula. So determine n, so basically put the numbers in. So 20.02 minus 5.74 over R2, which is 20.02 minus 10.31. So when you put all that in, so I get 1.471 or 1.47. So let's move on to the next bit. So the absolute uncertainty in each of the readings, R0, R1. Okay, so for the absolute uncertainty in this, so it's the uncertainty in R2, which is 0.04, plus the uncertainty in R0, which is 0.04. So that's 0.08. Okay, so you just got to add them up. Now, the absolute uncertainty in R2 minus R1 is the same as the absolute uncertainty in R2 minus R0. So this one is 0.08. Well, this one is 0.082. Okay, so calculate the percentage uncertainty in n. So the percentage uncertainty in n is equal to the percentage uncertainty. If you look at the formula, it's R2 minus R0. So the percentage uncertainty in R2 minus R0 plus the percentage uncertainty in R2 minus R1. So let's work it. So we know the absolute uncertainties. So we just got to do those over the values themselves. Plus 0.08 over the value. So for this one, R2 minus R0, so 20, so that's 14.28, and don't forget you got to times by 100. And this one, 22, so that's 9.71, and again times by 100. So what does that give me? That gives me this one is 0.56% plus 0.824% or 82%. So if you add them both together, so you get 1.38% or 1.4%. So just be careful. You got to work out the percentage uncertainties individually and then add them up because you've used both the top term and the bottom term. So you got to work out the percentage uncertainties for both. So another sort of question here. So determine the magnitude of the minimum gradient of a line that passes through all the error bars. So you got to make sure. So minimum gradient, the shallowest. So straight away, your brain is telling you, well, let's just do that. That will be the shallowest line. It will, but you've missed out these here, and you missed out that one. So it hasn't gone through all the points. So we need to adjust this such that it goes through all of them. So probably there. Actually, no, because I haven't got through this one here. So I'm going to have to go a bit higher. So probably be, let's have a look at that. No, I still missed it. So I'm just going to have to adjust accordingly. So again, there'll be a bit of tolerance, but you should be able to get spot on because it should be the top of this one and the bottom of this one. So now that goes through all the points. So then we just got to work out the gradient of that line. So this is 0.60. This is 0.2. So that's 0.25. So that's 0.23. And that's that. The whole thing is 0.4. So, and then just got to work out this difference here. So that's 0.6. So that's 0.37. Okay, so you just do 0.37, just check the units, voltage, amps, so there's no conversions of any sort. So 0.37 divided by 0.4, so that gives you 0.92 or 0.93. So the gradient is equal to 0.93. Okay.